Now, guys, when we have to plot the graphs of cosecant, secant, and cotangent, we will be learning this, keeping the graphs of sine, cosine, and tan in our minds. Okay? So let's start with the graph of um, cosecant theta or cosecant x. Acha, when I have to plot this graph, I'll go back to the properties or the critical values of sine x. So if you people recall your sine x graph or this sine x values here, I think I should write it sine theta. Okay. So you have sine theta 0 at 0 degrees. This is 1 here, this is 0 here, and this is minus 1 here. And if you remember, this is positive in these two quadrants, negative in these two quadrants. And overall, if you look at this graph, so its graph goes like this and like this. Okay, so it is 0 here, it is 1 here at pi by 2 or 90 degrees, and when this is 180 degrees, this is going to be 0, and at 270 degrees, this is going to be minus 1, and its cycle, its one wavelength is completed within these 360 degrees. So if I have to draw the graph of cosecant x, the first thing I need to realize that this cosecant x is clearly 1 over sine x. So rather learning this cosecant x from scratch, if we just go onto the values for this sine x, the sine theta, you will see that how would you be getting the critical values for the cosecant x here. So that is basically you have to write the reciprocals of all the values of this sine here. So your cosecant x is 1 over 0, so it would be approaching infinity here. And this is the reciprocal of 1 is 1. Again, the reciprocal of 0 is infinity, and the reciprocal of minus 1 is again minus 1. So if I have to plot the graph of this y is equal to cosecant x or the cosecant theta here, so you will see that now I need to have asymptotes. The asymptotes, remember those values, this is a very cute word, asymptote here, okay? So this is basically that angle or that value of x where your y would be approaching infinity. So you see that here it is approaching 0, this is 0 here. So we'll have at the same values of this angle, we'll have the asymptotes. There is already a vertical line here, okay? So I'll be having a vertical line here at 180 degrees because this is going to go at infinity at 180 degrees. And again, I'll have one more asymptote at 360 degrees. And if I go on drawing, like plotting this graph, so the next asymptote would be coming at 540 and then 720 and so on. And you can also have the asymptotes if you are going to go clockwise. So there would be an asymptote here at minus 180 degrees. So you have the reciprocal of 1 is 1, the reciprocal of minus 1 is minus 1. So let me draw these asymptotes with a different color here. So here is the asymptote, okay, at 180 degrees. Here is this asymptote at 360 degrees. And forgive me for not drawing exactly vertical lines here. Okay, so this is another asymptote over here, okay? So this is also an asymptote here. So yeah, there's already a vertical line here, okay? So don't mind that. So you see at 90, we have 1. At 270, we have a minus 1. And at this minus 90, you have again a minus 1, okay? So this curve would be going like this, like, here it is 1. So the moment, the way it approaches towards the 0, so after this 1 over here, this is going downwards to the infinity. So this would be going towards the infinity like this, okay? And again, this is going towards 0 here. So this would be going towards infinity over here as well, okay? So this is the part from 0 to 180 degrees. And here you are at minus 1. Look at this minus 1 going towards the 0. So from this minus 1, this will be going towards the infinity on both the sides here. Okay, so like this, this is so if the sine goes from 1 to 0, the cosecant will go from 1 to infinity. You can see this is 1 to infinity here, this is 1 to infinity here. So from minus 1 to infinity, this is from minus 1 to infinity. So that is how you complete this sketch for this cosecant. Okay, so you see this brown, if I can erase this graph of the sine from here, then you can see this clearly. I don't want to erase. This is looking so nice. So you see, this is the graph for your cosecant x. Okay, let's draw one more here. Let's say you have to draw here y is equal to cosecant x again without using this sine graph. So you see, you will have first of all the vertical axis, and then there is the horizontal axis. Here it is 0. Let me mark this in terms of pi. This time this is pi. This is 3 pi by 2. Here it is 2 pi. You have minus pi by 2 here. Here it is minus pi. You have 1 here. You have minus 1 here. Okay. And I'll have, there are my asymptotes over here. This is another asymptote. There is one more asymptote here. There is one more. Luckily, there are not many variations in these functions here. You simply need to learn how to sketch this, just this cosecant x. Okay, so here it is 1, here it is minus 1, here it is minus 1, and this graph will should look like, let me choose a good color here, better color, maybe the black one, okay, this time. So here is this, like coming from infinity, going towards 1 and then going backwards to the infinity. And here it is like, this and this, and this is going to be this. This cosecant x is never going to be 0. So from 1 towards, like this goes upwards, from minus 1 this goes downwards, from minus 1 this goes downwards. So that is how you are going to sketch the graph for this cosecant x. Okay, next I'll take you to the graph for the secant x. Okay, so now look at this in the same way. You can try this yourself. Okay, beta, just a minute. Yes, yes, beta. Yeah, yeah.
Yes, sir. Thank you.
Okay, so this was the graph of cosecant x. I'll tell you in the next segment the graph of secant x.